Right. Advent of Code, day 13. Yeah, great. That parsed correctly. What am I doing? These are, okay. Yeah. Mm, Ooh, I skipped over that. Why are you not? I really, yeah, I probably did this wrong, but this is weird. Why? Oh, they, okay, that'll do it. Yeah, okay. And then we do this depth limit because we have, okay, go, you're taking too long. Oh, yeah, that's not right. Okay. Oh, Oh, yeah, okay. Ugh, really bad. And this is exactly what I thought. And then we've got constraint equations. And this is why I really should have done a smarter approach using SymPy through Z3. I knew I needed to do. Yeah, yeah, yeah. Should have just done this from the beginning. Um, yeah, there is a more direct way. Yeah, yeah, yeah. Um, yeah. That sounds right. That is right. Great. Doesn't make sense. Oh, I see, I see. And then this gives me the 480. Okay, great. Um, okay, okay. Uh, would have liked to have been better. I probably would have been better if I went with my gut and started using the Z3 solver in part one, but we got there. Um, yeah, because fundamentally, this whole problem is a set of equations and optimizing the equations. In fact, I've got them really encoded right here. We've got uh, every time we press A and B, we move our X and Y, and we can just encode that because we know our target. We know where the prize is going to be. So this should bring back to just basic algebra in school. We've got essentially A times the AX delta plus B times the BX delta is going to equal PX. Another equation for the Y. We've got equation for the cost, just A times the A cost, B times the B cost, and we're optimizing this one. Now, for part one, I brute forced it. I brute forced it because it's small enough and you can just try literally every combination. There are some other ways you can do this that are probably pretty easy to implement, where you do some analysis. You see, okay, what potential values of A could you choose such that B then is still valid? Like, if you were to choose, uh, like if we take 0A presses, then we know that B must be 8,400 over 22. But this is not a whole number, so this is not going to work. So you can do some analysis, see which integral solutions there are to this, and then check each one. You can even start doing a binary search of that space to then do a minimization, which is probably what Z3 is doing under the hood. So for a manual solution, that's probably what you would want to do for part two. And I'm gonna talk about both these parts at the same time because really they're very similar. The only difference is, of course, part two. We move the prize out to a ridiculously far out spot. Um, so if I were trying to implement it myself, I would probably do what I just said. Do some sort of binary search on the integral solutions to these first two equations. Um, are the equations down here? To these equations, do a binary search in that space to then find where is the minimum cost. Or I could just let the Z3 optimizer solver do it for me. Which, once you give it the equation, it works really efficiently. Z3 and also SymPy. Um, well, I guess less SymPy here. I I believe there is another solver I've seen people use on the Reddit. I forget what it's called, but it can do very similar things. But yeah, Z3 did this very, very well. Just give it the equation, give it constraints for part one whenever we're uh, limiting how many times we can press the buttons, and just optimize this equation, and we get the answer. So to some degree, this is a bit of a cop out solution because I didn't fully write out the optimization, but hopefully gave a little bit of a idea on how you could do this manually. And I'm sure there's going to be plenty of solutions on the Reddit where they did actually solve this manually. But yeah, I have Z3 available. I am not above using Z3 to try to get to the leaderboard. I unfortunately did not. I would have jumped up quite a bit further in part two if I had just jumped to this earlier, but by the time I was thinking of doing Z3, I think it was already halfway through implementing part one, and I just went with the sunk cost. Probably wasn't the best idea, but it is what it is. Anyway, that's it from me for today, and I will be back tomorrow.